Welcome to AI Lab-Robotics series. This is the first tutorial and my name is Tony Lopez. In English probably is Tony or something like that. I never know how to pronounce. Anyway, in Spanish is Tony. And what we're gonna do in this tutorial basically is object recognition with a deep neural network called YOLOV3. So this is what we're gonna do. We're gonna take this picture and then we're gonna give this picture to process to YOLOV3, and YOLOV3 is gonna give us the identification of 3 objects with a percentage of certainty YOLOV3 has. So, just another clarification is like we're gonna use Linux, Ubuntu 18 and Terminal. If you are interested in Windows, please give us a comment down below, and then it depends how many people is interested. We can do another series with Windows for the neural network. In this case, we're gonna use Linux and Terminal. So for people that is not used to, it's gonna be a little bit hard, but for people that is already used to with Terminal, it's gonna be okay. So if you have any comment, please, give us the comment down below. And please, if you want to support the channel, give us a thumb up and subscribe to the channel. So let's start. Okay, let me put this here. What are we gonna do? First, Google YOLOV3, and then we're gonna follow these instructions. So here you can have an example of what YOLO can do with a GPU, graphical processor unit, not CPU. We're gonna start with CPU because it's much easier with, in this case I have i5, 01, 2.6 gigs and 4 cores, okay? So here just is an explanation, you can read it. It's basically saying that the YOLOV3 is very fast compared with other deep neural networks. So what we're gonna do, we're gonna follow these 3 commands that basically is download the darknet. The darknet is a AI framework similar to just to give you an idea, it's like TensorFlow. It's not the same, but it's similar. It's also written in C++. So we download, go inside the folder, and then make it compile. Okay. So I'm gonna use Tmax in Terminal, so I can have 2 screens and 2 windows, and I can show you how it's gonna process the information, how it's gonna do the inference darknet. So this is quite important because, as you're gonna see with CPU, it's very slow. So I'm doing Tmax, and then I do 2 windows. And so now we have the darknet compile, so we can use it. And next is download the weights. That basically the weights is the YOLOV3. Is all the structure of the deep neural network with all the weights and the weights in the connection. If you are interested to know more about deep neural networks, the theory, please leave a comment below and then we can explain. So basically, yeah, it's the YOLOV3 deep neural network trained already. It's already trained, so it's gonna work. So instead of download it, because it's very heavy, it's like 237 megabytes. I already downloaded it in a 1 folder app, as you can see here, 237 and YOLOV3. So the first time you have to download, and it for me was very slow, so just you press here and enter, and then it's gonna download for you. But to go faster in this video, basically I'm gonna copy from the upper folder, so I'm doing copy, upper folder, YOLOV3, weights, and I leave the file here in this folder darknet. Great, so we are ready now. I'm gonna use htop, and I'm gonna minimize a little bit. Okay, so here we have the 4 cores of the i5 I have. They are working quite heavy because I'm doing another process also. But we can see that the 4 cores are not 100%, right? So the next thing is that we're gonna give the picture JPEG that we can see here. I open another window, and if I'm doing EGO, that is a software to open pictures, and then I'm going to data folder and .jpeg, so we can see the picture we're gonna give to YOLOV3. Okay, this is the picture we're gonna do. We're gonna give the YOLOV3 to analyze, and we expect that YOLOV3 give us the objects that can see, right? So I'm close it, and then I'm gonna compile. Do the inference. So to do the inference, basically is this command that is gonna process the image. It's gonna take all the pixels of the image, insert in the deep neural network, and then it's gonna give us the results. So this i5 CPU is quite old processor, the one I have in this laptop. But anyway, with CPUs it's very slow, really slow, because CPUs are meant to process in series, not in parallel. And what we need is like process a lot of parallel things. So with CPU is gonna be very slow. If you want to analyze videos, that is a series of image, of course, then we have to process very fast. And as you can see here in the example, it's like 0.02 seconds, and we get 37 seconds. Why is that? Because they use GPU. That is a little bit more tricky because we have to configure all the several configurations that are a little bit complex, and is not going to be in this video. If you are interested to know how to configure your GPU, especially will do for NVIDIA, not AMD, please give us a comment, and then we will do with GPU that is a little bit more complex. So in this case, with the I didn't show you that was using just one CPU. Yeah, we can do again. So I can do another window, and first I'm gonna do again. So I give the picture to the YOLOV3, and it's gonna process it. It's gonna do the inference, and as you can see, once I start the inference, is using just one CPU, one core, 100%. So we can do that. They use more than one core, and I will show you how. So let's do that. So we have this folder with darknet, and is compiled for one core of the CPU, right? So if we want that darknet, so the AI framework, use the 4 cores to process the image, then we have to compile again, changing some parameters in the make file. So how are we gonna do that? The first thing is, sorry, I forget one small detail. So here is the prediction, dog, track, bicycle, and the probabilities, the certainty that the AI has. And then if we want to see the boxes, we go into the darknet folder, and we have predictions that we didn't have before. And we do a geo predictions, and then we see the boxes. So we have where the AI think is the object in the picture, and also the tag. And also here we have the parameters and the certainty, okay? So let's do with 4 CPUs. With one CPU, we were between 31 and 39 seconds. So now let's do with, 4 CPUs, no, 4 cores. So we want to do the same, but changing the parameter in the makefile. But first, I have to delete the darknet, or let's delete. So I'm doing R darknet. So I delete the folder, put my password, and then we don't have any more darknet. Okay, so now what we're gonna do is download it again. So I'm searching for the command. Was get. Anyway, so we copy from here. Git clone. Git clone. Okay. So I'm searching for git clone. I'm looking for the command that I wrote before. Okay, this one. With Control-R, you can search for commands you did before. So now we don't load again the darknet. And once it's load, we're going again to the folder, darknet. So we are here. Let me, yeah. So we are in the darknet folder. And as you can see here, we have the makefile for the compiler. So we're gonna do B, that is text editor for Linux, and makefile. So we're gonna edit. Let me do it big. And so basically, yeah, we're gonna change this parameter, open MP. As you can see, we have different parameters, and mainly these two here, the GPU and CUDA engine is for the GPU, but we don't gonna do in this tutorial. And OpenMVP is for the CPU. So what we're gonna do is telling the compiler that yes, with one, we want to use all the cores available. So this is the config file. We are ready to go, but let me put also the debug and see what happened. I'm gonna tell also we want to see the debugging. So I save and close. We come back to all the windows, and now we can compile. So let's compile, make. Okay, so we are compiling with 4 cores now. So I just keep this window because I want to keep the time. It was 39 with 1 core, 39 seconds, right? So now what we want to do in this step after compiling, we should download the weights. That is the YOLOV3. And as before, I have the folder in one app, the upper directory. So I take the weights and I move to, I copy to this directory, and we have here the weights. So we are ready. And then we do again the same command that basically is processing the doc image. And once start the inference, now we see the 4 cores should go 100%, or I don't know why not is going 100%, maybe because there are other processes, but it's almost 100%, and also I'm running out of memory. So it's using all the CPU that the operational system give access. And then we're gonna see the difference in time. So so it's 27 seconds, it's not so much difference. We have the same prediction, and we can see it also, it's the same. So as you can see, it's not so much difference. Why? Because really the GPU is like, really has a lot of cores, hundreds of cores. It depends on the GPU even more. And here just we have 4. So we cannot process parallel the deep neural network. And for the reason it's so slow with CPU. So again, if you are interested to do with GPU, or in another way to process videos, like in the demo here, in this website, then we need to config the GPU. And it's gonna be a little bit tricky. So if you're interested, leave the comments below, and then we'll do the video with GPU. So thank you very much, and I hope you subscribe and give us a thumb up. Even if for me was this the first video and was a little bit difficult, but hopefully you like the information, and we can keep growing the channel. Thank you very much, and see you in the next one.